Now we are discussing about applications of the elastic behavior of materials. The elastic behavior of materials play an important role in our everyday life. Every engineering design requires a precise knowledge of the elastic behavior of materials. For example, if we take the design of a building, or if we take the design of a bridge, or design of a ship, aeroplane, for all these materials, for all these constructions or designs, we have to use those materials and which we know the elastic behavior of the materials. Based on that only we can tell what is the capability of this bridge, how many persons at a time can withstand on this bridge, how many persons can travel in this particular plane, like that we can tell. So one small application we will take. I think you all know what is crane. Generally, we use the cranes in order to lift the heavy loads, which it is very difficult. Sometimes, whenever we are digging the big mountains, those rocks, one person or two persons or 10 persons, for them to take that big rock, it is very difficult, which is 10,000 kgs. For human beings, it is difficult to carry those rocks. In ancient times, they carried with the different principles, they used the different tactics to carry those rocks, and that's how they built the magnanimous architectures in India. But in modern days, we use a particular concept of the elastic behavior of a metal rope. Whenever you observe the lifting of a crane, this time you observe they use a metallic rope. This metallic rope is tied to a pulley. By using motor, we can lift the load with the means of this metallic rope. Example, if the load is 10,000 kgs, once we lift the load, after that, whenever we are lifting the load, at that time this metallic rope elongates, its length changes obviously. But after the lifting of the load, the metallic rope should come back to its original position. Then only we can use the crane for the next load lifting. So if by chance it is not coming to its original position, then that wire is gone. It is no more useful for lifting of the further load. So that's where the concept of the elasticity comes in. Until what load we can lift. So for that we already discussed the area of the cross section of the wire should be greater than W by sigma y, where sigma y is the Young's modulus, W is mg, m is the mass of the material, that is 10,000 kgs in this case, and g is the 9.8 into meter per second square. Sigma y is Young's modulus. Based on that, we can calculate what is the area of cross section of the wire. Similarly, if a person comes with a requirement, the crane which I use should be capable of lifting 10 lakhs kgs. Then as a design engineer, we have to give what is the thickness of that metallic wire. That's how, knowing the elasticity of a material, studying this topic, we are capable of understanding in real time how much thickness of the metallic rope is required to lift the loads when we use the cranes. We will take one more example. This time, we are taking a bridge. See, sometimes we hear in the news that the bridge got collapsed. Recently, also, we heard the news why this problem is coming. Because the persons who are staying there, they don't know what is the maximum capability of that bridge. So, if we say, example, the bridge is capable of withstanding for 1000 kgs. Remember, for example, we are considering. So the 1000 kgs, if we take only the human beings, sometimes wind also comes. We have to calculate that also. And the bridge also has its own weight. So based on this only, they will calculate and finally they will tell a less number. So they have to estimate all these. At that time, elastic limit or elastic material of the material which they used for the construction of the bridge, it plays an important role. Otherwise, n number of people may come for a particular event, so the bridge may collapse. So in order to avoid that, while designing the bridge, the engineer tells this is the limit of this bridge. This much weight at a time, this bridge can be capable of holding. So at that time, in order to decide that weight by using the real-time scenario, because every time the wind speed changes, that also we have to consider as a weight that is acting on the bridge. Based on that, the engineer gives this is the load we have to use when the wind is more. This is the load we have to use when the wind is less. This is how an engineer tells. Similarly, it applicable even for the aeroplane or for the ship. So in all these designs, we have to know the elastic behavior of the material. Then only we can tell what is the maximum limit of that particular machine, or what is the maximum limit it can withstand without deforming permanently. It has to deform, but within the elastic limit, it has to deform. Whenever we are applying the load on a particular material, definitely it deforms. There is no doubt. It is according to the Newton's laws. But we accept the deformation, but we do not accept the permanent deformation. It should come back to its original position once the load is removed. That's what we say. When it is applying that, when it is considering that, then it is within the elastic limit. That's where whatever we studied, the Hooke's law is getting obeyed.